Hey thinkers, welcome to Think Sharp Alley, where every turn leads to a smart solution. Hey learners, welcome to part 1 of the Congruency of Triangle series. Today we will learn the 5 powerful rules that helps us decide if two triangles are exactly the same in shape and size. We'll also solve a few simple questions to understand them better. So let's begin our journey to master congruency. Two triangles are said to be congruent when their corresponding sides and corresponding angles are exactly equal. That means if you place one triangle on the other, they will overlap perfectly. But we don't always need to check all 6 parts, which means 3 sides and 3 angles. With just 3 elements, we can prove congruency using the 5 rules that we are going to learn. Well, there are actually 6 criteria of congruency of triangles. Let's have a look at the first one. The first one says SSS congruency criteria, the easiest one. The 3 sides of one triangle is equal to the 3 corresponding sides of another triangle. The word corresponding sounds fancy. We'll come to that later on. So let's have a look at triangle ABC and triangle PQR. Here you can clearly see AB is 3.5 cm, whereas PR is also 3.5 cm, AC is 5 cm, RQ is also 5 cm, and PQ is equal to BC, both equal to 7.1 cm. But before we jump into solving questions, here's one thing that most students miss, and that's a total deal breaker in congruency proof. That's what we're talking about, correspondence. Fancy word, but it simply means matching the right parts of one triangle with the right parts of another triangle. So when two triangles are congruent, the order in which you write their names matter a lot. For example, in these 2 triangles, you see vertex A that lies between 3.5 cm and 5 cm. So in this triangle, between 3.5 cm and 5 cm lies vertex R. So A is corresponding to R. Vertex B is corresponding to vertex P, I guess, because B lies between 3.5 and 7.1. So over here between 3.5 and 7.1 we have vertex P. So the remaining one, vertex C, corresponding to vertex Q. So if your triangle name game is wrong, your proof will collapse like a tent with the wrong poles. So that's why always match the first angle with the first angle, second angle with the second angle, and the third angle with the third angle. It's like you're playing musical chairs with the triangles, and each vertex must sit in its exact corresponding chair, or there will be chaos. So while proving the triangles, if you're not writing the names of the triangle properly, you are wrong. So over here we write the parts. After naming the triangle, we write 3 equal parts. Over here 3 equal parts are 3 sides. And then comes the golden statement. Triangle ABC is congruent to triangle RPQ by SSS axiom. So if anyone over here writes triangle ABC congruent to triangle PQR, it would be wrong, or that person might have misread the figure. Because congruency is not just about matching angles and sides, remember that. It's also about respecting the order like good triangle citizen. So now I'll show you 2 triangles. Pause the video and try to write their names in the correct corresponding order, and then check if your sequence matches mine. First 2 triangles. If you see DE, EF and DF, all the length are given. And in this triangle also all the lengths are given. Can you write the names of the 2 triangles in a correct order? Don't worry in case you have missed it. So here we have triangle DEF congruent to triangle NML, because DE is equal to NM, EF equals to ML, and DF equals to NL. All 3 sides of this triangle is equal to corresponding sides of this triangle. And we have found the correspondence as well. So triangle DEF is congruent to triangle NML is the correct writing. Now if we see in this triangle, AB is equal to AC, BD is equal to DC. And what about the third side? Third side is AD, which is the common side. So these 2 triangles are also congruent to each other, by SSS axiom, and the correct name will be ABD, congruent to triangle ACD. You can match the correspondence and check. If in case you're having any doubt, please write down in the comments. Next criteria for congruency of triangles is SAS congruency criterion. In this rule, we need two sides of a triangle and the angle between them. That's why we call it the included angle. For example, you see triangle ABC and triangle DEF. AB is equal to EF, each equal to 7 cm. BC is equal to DE, each equal to 5 cm. And the angle B is equal to angle E, which is in between the sides that we are considering. Yes, the angle has to be sandwiched between the two sides, not hanging off at the corner. It's like a triangle sandwich. Remember it? You can't call it an SAS sandwich if the cheese is falling off the side, right? So many students make this one mistake. They take any two sides and any angle, but that's not SAS. If the angle is not in between, it doesn't prove congruency. Now let's check the correspondence over here. So if you see, A is between 7 cm length and nothing. So between 7 cm and nothing, we have F. So A is corresponding to F. B is corresponding to E because angle 50 is marked. And C is corresponding to D. So if I name triangle ABC, another triangle's name will be FED, not any random order. So AB is equal to EF, BC is equal to DE, and included angle B is equal to included angle E. Remember the sandwich method? And the golden line, triangle ABC is congruent to triangle FED by SAS axiom. So can you examine whether the two triangles are congruent or not by using SAS congruency rule? So if the triangles are congruent, you can write them in symbolic form. So over here we see 4.5, AB is 4.5, whereas DF is 4.5, great. My AC is 4 cm, so do DE is 4 cm. But included angle A is not equal to included angle D. So we cannot say that the triangles are congruent. What about the next figure? In the next figure, we do have two pair of equal sides and one pair of equal angle. But can we say that it is SAS congruent? Of course not, because the angle that is given equal is not the included angle. As I had said, that angle has to be sandwiched between the two sides I'm considering. So it's not. So these two, we cannot apply at least SAS congruency rule over here to prove them congruent. So here's a quick way to remember. If you walk along one side, take a turn at the angle and continue to the second side, that's SAS. But if you take the angle first and then jump to a random side, then to another side, that's ASS. Remember SSA, ASS or AAA, AAA do not prove any congruency. They might try to trick you. Now let's move on to another triangle congruency rule, that's ASA axiom. ASA stands for angle side angle. In ASA, we are given two angles and the side that lies between them. So here you can see in triangle ABC and triangle DEF, if we check the correspondence first, here angle A corresponds to angle F. It's very easy when angles are mentioned. So finding correspondence becomes as easy as possible. So angle B corresponds to angle E and angle C is nothing, so corresponds to angle D. So if we have to name the triangles, it will be triangle ABC and triangle FED. So the parts that are equal are AB is equal to EF, angle B is equal to angle E, and angle A is equal to angle F. So the triangles are congruent by angle side angle axiom. Again, the placement is key here. The side must be between the two angles. You can't just pick any two angles and any side and call it ASA. Otherwise, our triangle proof will go from angle side angle to all scattered assumptions. Now don't confuse this with angle side. We will talk about that in few minutes. So just remember, in angle side angle axiom, the side has to be sandwiched between the angles, like the filling in a geometry burger. Now that you have met ASA, it's time to meet its close cousin AAS. This stands for angle side. Sounds similar to ASA, right? But this one's got a little twist. Here we are considering two angles and a non-included side. So if we have a look at the figure, we have two angles given equal and one side, which is not between the angles. It is attached to one of them, sort of off to the side, but not in between the angles. So let's check the correspondence over here. Since the angles are marked, again the correspondence becomes little easy to notice. Like for example, L corresponds to T, K single angle marked corresponds to U, and M corresponds to S. So we can name the triangle as LKM and TUS. It's still true. And we have three equal parts, LK equal to TS given, angle K equals to angle U, angle M equals to angle S. So the triangles are congruent by angle side axiom. So in ASA, the side was sandwiched between the two angles, but in AAS, side is on the outside, a little flingy you could say. So if your triangle side is shy and hanging off the edge, it's probably an AAS. Anyway, so in triangle life, it's not always about being in the middle. AAS proves that even sidekicks can make things congruent. So let's move on to the next congruency criteria, that's RHS. This one's special. This is because it's only for right angle triangles. If hypotenuse and one side are equal in both the triangles, then only the triangles are said to be congruent. So remember, if it's not a right angle triangle, you cannot use RHS. So RHS triangles need just a right angle and hypotenuse, remember, and any one side. So if we have a look at these two triangles, here we have one right angle, angle B is equal to angle Q. Now let us check the hypotenuse. Hypotenuse is AC over here, and opposite to right angle, that means hypotenuse over here is PR, which are also equal. And last side BC is equal to QR, 3 centimeters. So we can say it is RHS congruency. Now let's have a look at the correspondence. Obviously, if angle B is corresponding to angle Q, 90 degree marked, then we have A. A is between nothing and 6 centimeter. So between nothing and 6 centimeter, we have P. So A is corresponding to P, and the remaining side C is corresponding to R. So here the triangle's names are ABC and PQR. We note the three equal parts, and hence the triangle ABC and triangle PQR are congruent by RHS axiom. And that wraps up all 5 congruency rules that you need to master and the ones which you shouldn't use. Now that we have cracked the rules, it's time to apply them. In the next video, we'll solve 10 simple, smart triangle congruency questions step by step. So don't worry, no triangle drama, just triangle
So
command.
hit that subscribe button, tap the bell icon, and get your notebooks and brain ready. Triangle proof practice is coming your way. Till then, stay sharp, stay right angled, and stay congruent only on Think Sharp Alley.